Hello, Professor. This is the video recording for the assignment number 2. We are a team of two, Supreme Tapa and myself, Pablo Hernandez. We are presenting here the part number 1 of the Azure Machine Learning Studio with the auto price prediction. So here we follow up the demo file for the creation of this assignment that you provided to us. So here is the main page that we created. As the demo said, we started with the automobile dataset that was provided here in the sample dataset. We're going to predict the price, the price data automobile. The second step that we did was use the select columns. We selected all columns and normalized losses. We used a filter that will clean any missing data, removing the entire row. After that, we add another step. Here we are selecting columns in the dataset, so we are here selecting the more impactful or relevant data that we have in our dataset for our analysis: make, wheelbase, engine size, horsepower, RPM, price, and body style. So after that, we are going to split the data for the training. We are using 75% for the split. After that, we are going to train the model, and we are going to use a linear regression method for this procedure. After the training, we are going to score the model with the rest of the split data that we used, that we take, and here we're going to get a value of the model, and at the end we are going to evaluate the model. So we run the code in our Azure Machine Learning Studio. So here is going step by step, and after it's done, we can see the results here in Visualize. So here is a little plot, an histogram plot that it's showing the error. Also, it's showing some data about the mean, root mean square, absolute error, coefficient determination. So here we can view a little bit more data as well. All the data that we selected: make, body style, wheels, base, engine size, and see the score labels, the mean, median, all the important values, the statistic values of what we did. And we used here all the resources provided by the Azure tutorial. So that will be it for now, Professor. We're going to finish the part 1 here. See you on the part number 2. Thank you. Hello, Professor. This is the part number 2 of our assignment number 2. We are going to move on to the German credit data. Based on the steps that you provided us in the demo file, we follow them to do the completion of this assignment. Moving on to the first part of our assignment number 2. Here we go into experiments, and we go to our file that we already created. Starters, we downloaded the dataset provided that we found in the page statlog. That's the German credit data. This project is for the credit risk prediction from the customer credit application data. This experiment is entirely based on whatever data we got from statlog. We downloaded the dataset and we converted it into CSV and we uploaded it into our site and we drag and drop into our code. After that, the step number 2 is edit the metadata. As our dataset doesn't have any headers, we are going into this step to select all the columns. As you see, we see all the columns with no name, and we are going to insert the name of the columns for our dataset to make it more understandable for us. After that, we are going into the step number 3, that is splitting the data. For this split, we use the automated or the standard value that is 50%. So we went on with that value. So we are splitting in half our dataset. For the next step, we are going to introduce our script code. With this code, we intend to avoid the misclassification of the risks. So in our dataset, we have in our columns we have number 1 value and number 2 value that stand for high and low risk. So we are going to split the data based on that values. And after that, we are going to apply a multiplication factor of 5 so we can determine better the high and the low risks. And after that, we are going to introduce it in our dataset. That's what we did in these 2 steps for both of the splits. After that, in the left side, we are going to train our model, and we are going to use a 2-class boosted decision model. After training our model, we are going to do a score based on whatever we got from the trained model and our rest of the data that we didn't train. And for the last step, we are going to evaluate our model. Now moving on to the right side, after we went to our R script step, we are going to normalize our data. For this step, normalize our data, we are going to include the numeric columns, and we are going to exclude the credit risk that we used on the left side. For this normalized data steps, we took both of them that went for both splits of our data. After this normalized data, one side is going to the trained model with a 2-class support vector model, and the left side is going directly to the score model that is going to take also the trained model. And at the end of these steps, we are going to take the score model from the left side of our code and the right side. So we are going to get one result. After inputting all these steps, we click the run button so it can compute. After finishing each one of them, we are going to be able to view the data that we got from our code. So here we have our plot of true and false positive rates that are pretty similar between both of them. And here we're going to see the precision and the accuracy values of our code and the data the data used for these results. That will be this part of the code. And for the last part of this assignment number 2, we are going to deploy the web service. So I didn't show, but in this step, there we put the setup web service. We go for the recommended version, and it will create us this file. Then we will go ahead and click on the test link. So here we got the page. We selected our sample data activated, so we can get instantly a random sample of data that we can. It will be much easier when we need to test. So here we click on test, and this is the row of the output that we are getting through our model. We also go to dashboard and see whatever activity we are having with this web service that we built. And also, whenever we create this web service application, our code is going to be transformed, so changing some steps into more traduce that whatever steps that can be handled by the web service. And also we took out some of our own code to run this application. Thanks a lot, Professor. That will be all. Thank you.